not last forever, and eventually the intense reaction that causes a star to burn will stop. The Sun was born roughly 4.6 billion years ago, and without its heat and light, nothing on Earth would exist. Every second it consumes more than 600 million tons of hydrogen and converts it into helium, a process known as nuclear fusion. It is currently halfway through its most stable part of its life cycle and is classified as a main sequence star. But just like all of the other stars out there, the Sun only has a limited amount of fuel, which means eventually it will die. However, long before our star disappears, life on our planet will be faced with its greatest ever threat, an aging sun. Every billion years or so, the Sun by around 10%. This means that the Earth will become continuously hotter and brighter the older the Sun becomes. Many scientists have estimated that in 1 billion years from now, on average, the temperature of Earth could be around 70 degrees Celsius. If they are correct, then over time, animals and plant life would likely perish due to this increased heat. As the heat continues to increase around 2 billion years from now, the oceans, seas, rivers and lakes would slowly evaporate into the atmosphere, causing a greenhouse effect to occur, and the surface of Earth would become a desert world. But the Sun hasn't finished yet. Around 4.5 billion years from now, it will have used up its core hydrogen supply and start to burn helium instead. This will cause the outer regions to swell and expand outwards into the solar system. Because of this, the Sun is no longer a main sequence star, but is now classed as a red giant. The expansion of the red giant will be devastating for the inner planets, Mercury and Venus, as they are vaporized by its ever-growing surface. The Earth at this point will either share the same fate or will be so close to the red giant that it becomes burnt to a crisp, maybe resembling something like today's Mercury. The outer planets of the solar system would warm up, and moons like Europa would thaw. Its miles thick icy crust would melt into a liquid under the heat of the red giant that is now 20 times larger than the Sun we see on Earth today. When the Sun's supply of helium is nearly depleted, it will become completely unstable and start a series of thermal pulses. Within time, these pulsations will blast away its outer layer until all that is left is an object about the size of Earth, called a white dwarf. Surrounding the white dwarf will be a planetary nebula that could be visible for any civilization existing within a few hundred light years of our former stellar neighborhood. But the feeble white dwarf at its center, that once was our mighty Sun, will slowly cool and fade until it becomes cold and dark. Then the Sun
Girl, you know I want your love for Sunday, for somebody like me. Come on now, follow my lead.